All right, folks, so picking back up with our observations of planets. This is video 14. We're continuing from video 13. And we were sort of in the middle of our third of 6 observations. And that third observation was that planets mostly go west to east. And over enough time, they will go west to east. But occasionally, they back up. It's like sitting there at the running track, the circular running track I asked you to imagine, and having somebody walking forward and then backing up for a little while, then walking forward again, and then backing up a little while and moving forward again. Overall, they're moving forward, but 2 steps up, 1 step back kind of deal. They're still progressing, but more slowly than they would if they didn't periodically back up. That's what happens with the planets. That backwards, so-called that backwards motion, east to west motion, the motion right here, as it goes from east to west, is known as, this backup motion here is known as retrograde motion. And by the way, there are 2 points here involved. The easternmost point here and the westernmost point there are known as the eastern and western stations of the planet's motion. Okay, so when it stops moving east and right as it reverses direction here, that's known as the eastern station. I'm not going to write it on the board. This one here, before it resumes its forward motion, is known as the western station. So that is a third observation made by the ancients, and it turns out that it happens on a regular basis. Okay, for Mars, for example, it is retrograde RG every 2.1 years. You can bank on it. Every 2.1 years, Mars backs up and then goes forward again. It's regular. It's not random. Okay. Neither is the size of its loop random. Okay. The size of Mars's loop, it varies a little bit, but not so much that we could tell with our unaided eye. But it happens every 2.1 years. Okay, for Mars. And it's a similar number for other planets, Jupiter, Saturn, Venus, so forth. All 5 planets do it. They all have different times between these reversals. Okay, but the reversals all happen on a regular basis. Okay, so it's a regular, periodic, like clockwork business. Okay, so that is observation number 3. Observation number 4 is this. Let me see what I got here. Retrograde. Oh, by the way, I knew there was something else I wanted to say. The forward motion, the regular west to east motion, is known as prograde. The standard forward motion of the planets from west to east that happens 90% of the time is known as prograde motion. And then when it backs up and goes east to west, that's retrograde motion. Okay, it's that term prograde. I wanted to make sure you knew that. So retrograde RG, I'm going to shorten it RG, motion occurs I'm going to get my notes here. It's a little bit wordy. I don't want to get the words right. Occurs for Mercury and Venus when they are at conjunction. I'll tell you what that is. For Mars, I'll go and spell out Mars here. Mars, Jupiter, and Saturn, it occurs when they are at opposition. Okay? These are two important terms, conjunction and opposition. Take a minute to tell you what they mean. Conjunction and opposition. Conjunction is like the new moon. Conjunction is when you're looking at a planet moving around and it's in the same direction as the sun. Like the new moon, for example. That's called conjunction. When the angle between the sun and the planet is 0 degrees, when they're in the same direction in the sky, doesn't mean they're close to each other, just means they're laying in the same direction in the sky, that's known as conjunction. And so for Mercury and Venus, they do their backup retrograde business when they're in the same part of the sky as the sun. But Mars, Jupiter, and Saturn does not happen that way. For them, retrograde motion happens when they are opposite the sun. So opposition means that the planet is in the opposite direction from the sun. So it's like the full moon. So if conjunction's like the new moon and the moon's in the same direction as the sun, opposition is like the full moon. It's in the opposite direction from the sun. 180 degrees between the sun and the planet. That's opposition. When they are opposite in the sky. Look over there, you see the moon. Look over there, you see the sun, directly opposed to each other. They couldn't get further apart in the sky. Okay, that's opposition. And for Mars, Jupiter, and Saturn, they go through retrograde motion when they're at opposition. But Mercury and Venus go through retrograde motion at conjunction. When they're close to the sun, Mars, Jupiter, and Saturn, it occurs when they're far from the sun. So conjunction is as close as you can get to the sun in the sky. Opposition is as far as you can get from the sun in the sky. Okay, and the ancients noticed this as well. Mostly I'm talking about the Greeks, but it was noticed by ancient cultures all over the world, of course. The Greeks didn't have a monopoly on this. 5. Retrograde happens when Mars, Jupiter, and Saturn, can you see that? Yes, you can. Mars, Jupiter, and Saturn are brightest, are at their very brightest. Planets do not maintain the same brightness all the time. In this way, they're different than the sun and the moon. Sun and the moon, I mean, the moon goes through phases, but every full moon's about as bright as every other full moon. And the sun is always the same brightness, but the planets go through noticeably different brightnesses. And retrograde happens when Mars, Jupiter, and Saturn are brightest. So they go through retrograde when they're brightest, but this is not so for Mercury and Venus. So retrograde motion happens when Mars, Saturn, and for those planets, Mars, Jupiter, and Saturn, retrograde motion happens when they are very bright, as bright as they ever get. Every 2.1 years, Mars gets really bright, it undergoes retrograde motion, and it also shows up at opposition. Okay, those 3 things go together for Mars. It gets the brightest, it undergoes retrograde motion, and there's opposition all at the same time. For Mars, for Jupiter, for Saturn. Not so for Mercury and Venus. Okay, Mercury and Venus both undergo retrograde motion at conjunction, but they're not brightest then. Okay. Finally, number 6. I think I'll stick this. I didn't write this in orange. My yellow is getting quite worn out. Number 6. Mercury, Venus always stay close to the sun. Mars, Jupiter and Saturn do not. If you think about the running track, okay, so we have a track with 7 runners on it. And we're just looking at one part of the track here. We're not looking at what's behind us, just one little section of the track. Once per year we see the sun pass in front of us, right? It goes back around us. Okay, we're still got the stars fixed, we're still lying there on our backs. We would see the sun pass, even if the Earth is not rotating, we would see the sun pass over our head, okay, once a year. It would complete a loop around the running track of the ecliptic once per year. So we would see it pass every year. 1 year, like maybe it's, July. Every July we'd see the sun go by. And in that same amount of time, we'd see the moon fly by 12 or 13 times around the track. We're looking at one little part of the track. Okay, we would also see occasionally a planet drift by. And they would all occasionally back up and move forward again. That's the retrograde motion. Number 6, what it's saying is that something is odd about Mercury and Venus. Mercury and Venus are never far from the sun. Whenever we see Mercury and Venus, we can be sure the sun is nearby. It's almost like the sun was a dog walker, and Mercury and Venus are 2 dogs that are sometimes running ahead of the sun in its yearly path around the ecliptic. Sometimes the dogs run ahead of the sun, sometimes they drag behind, sometimes they run ahead, they see a squirrel, they run ahead, sometimes they fall behind, they get interested in smelling something, or they gotta go to the bathroom or something. So the dog is continually running in front of and behind the dog walker. Sometimes the dog is running faster than the dog walker, sometimes the dog is running slower and actually backing up. But Mercury and Venus are like 2 dogs on the sun's leash. Okay? They're never far from the sun. It turns out that Venus's leash is a bit longer, about twice the length of Mercury's. But they both stay close to the sun, sometimes running ahead of it, sometimes running behind. But on the average, they're making a loop of the sky once per year. Those are the observations of the planets. And add those in with the observations of the sun, moon, and the stars, and we have ourselves a scientific problem. Okay? I am spending some time in this course on historical astronomy. This whole week is going to be historical astronomy. Stuff that happened in the past about astronomy. And I'm spending time on it for a very particular reason. Listen closely, please. It is because I want you to understand that science is not just a pile of facts. Okay? I mean, facts are involved in the same way that dollars and cents are involved with economics. But economics is not simply about dollars and cents. It's about systems. Okay? It's about supply and demand. It's about all kinds of things. Yes, it is really made up of, money, dollars and cents. But to understand it, you have to understand more than individual dollars and cents. Science is a way of organizing facts. Okay, it's a way of organizing them. It's a way of investigating. And it's not all about facts either. It's a process. Science ultimately is a very human enterprise. And the reason why I'm spending time showing you all these observations here and spending time on historical astronomy in this second week of class, is because there's a particular episode in the history of science that really helps the students to see how science works, and that it is a process, and that it's not just a collection of dry facts. Okay, so what we have here, and I'll come back to this in a moment when we start our next video. What we have here, okay, is a collection of observations. And the challenge that scientists pick up is to take all of these bizarre sounding observations and put them into a model. Come up with a conceptual model of the universe in which all of these different observations makes sense. Okay? That puts them together, that makes them harmonize with each other in such a way that they can all be understood in terms of one simple picture. Okay? So these shared observations everybody has known, okay, for thousands of years. But the question is, what does it mean, and how can we build a single and simple conceptual model that takes all of these facts and makes them harmonize and work together in a simplest possible way? That's a scientific theory. We're seeking a theory. And the rest of this week is going to be about two competing theories that both explain all these facts. But one of them's right and one of them's wrong. And I look forward to showing you how that works, starting with video number 15.